I'd like to spend a little bit discussing the role interfaces play in actually implementing classes. Okay, the pen classes that we talked about in the Turtle graphics package, it's a little complicated, so we actually won't discuss how they're implemented right now. But we can work with a slightly simpler example. Suppose we need to perform some very basic manipulations on circles and rectangles. That can mean positioning, could be moving, stretching, any of these basic geometric shapes. We also want shapes to implement methods that compute their area, draw themselves with a pen, and give us descriptions of themselves back. Now, without even caring about implementation details, we can just describe this behavior in an interface called shape. Okay, and that's shared by all circles and rectangles, and we can see the code here for it. So we can see a shape can give us its area. It can draw itself using a pen that's passed in as a parameter. We can get its X and Y position. We can move it somewhere. We can stretch it, and we can return a string representation of it. Now remember, this is not a class. You can't instantiate a shape. All we're saying is that any class that implements this shape interface, any class that is a shape, has to have these specific methods. They can have more, but it has to have at least these. We'll implement the circles and rectangles in classes that we'll call circle and rect. Okay. We don't use rectangle because Java already has a class with that name, so it would confuse things. It's a bit of a hassle to work with two classes that have the same name, but we don't want to bother with it right now. The general outline for implementing these classes looks something like this. We have a public class circle implements shape. That means the class circle is going to adhere to the shape interface, and same for the class rect. Again, all this means is that both classes are going to implement all the methods listed in the shape interface, and any variable declared as a shape, any shape variable, can be associated with an object of either of these two classes. It means we can point a shape variable at a circle object or a rect object. Okay, and now we'll take a quick look at the two classes themselves, circle and rect. We'll go through these very, very quickly, but I encourage you to spend a little bit more time. Either pause this slide and take a look at the code here, or open it up in the code for this unit. So here we can see the circle class. Up at the top, we see it implements the shape interface, and that means that we have to have all of the methods of the shape interface, which we have. We've got constructors, we've got the area method, draw, which takes a pen and actually draws it. We've got getX position and getY position. We've got move, stretch by, and toString. All of these are the methods of the shape interface. You can see here we also add instance variables, X position, Y position, and radius. Okay, here we got the rectangle class. It's pretty similar. We've got instance variables, X position, Y position. Here, instead of radius, we have two instance variables, height and width. And we've got constructors as well for rect, both the noarg and one that takes all the instance variables as parameters. Again, because we're implementing the shape interface, we have to have area, draw, getX position, getY position, move, stretch by, and toString. So we can see we have two separate classes that both implement the shape interface, but show us different implementations of those methods based on what that class is supposed to be. Now, the code for those two classes is actually not too difficult to understand, so we'll write a little program that can test the shapes. Here we can see in the class test shapes, we've imported Turtle graphics and color and scanner. We start by instantiating a pen and making a circle and a rectangle, both of which are pointed to by shape variables. Okay, you can see in general, we prefer to use an interface type if we can. Then we draw our shape and our rectangle, and we print the string representations to the console, and we wait for the user to hit enter. As soon as they hit enter, we erase the circle and rectangle, set the pen's color to red, redraw them after moving them and changing their size. So you can see here, they're shown this way to save space, but we'll move S1, we'll move S2, we'll move stretch S1, stretch S2, and then redraw both of them. We can see the final result of this program here. Start with a blue circle and a blue rectangle, and after hitting enter, we end up with a red circle and a red rectangle, both of which have been stretched. Okay, so a few assorted final thoughts. An interface only has methods. It doesn't have variables. That's crucial. We typically make all the methods in an interface public. So helper methods will typically leave out of an interface. And if we have more than one class that's going to implement an interface, which is typically going to be the case, we'll say that its methods are polymorphic. Right? Those methods, the ones that are being implemented by multiple different classes, they have different forms. That means that if we have a variable of the interface type, for instance, a pen variable pointing at a wiggle pen, or a shape variable pointing at a circle, and another shape variable pointing at a rectangle, the compiler will be able to tell which version of the method to run. So we can see here, I have shapes S1 and S2 pointing respectively at a circle and a rect. They both have the method area, and that means area is polymorphic. There's more than one form of area. There's the form of area associated with circle objects, and there's the form of area associated with rectangle objects. Now, if you implement an interface, the class that's implementing the interface can have other methods too. You don't only have to have the methods in an interface. So for instance, a circle, we could add methods other than ones that are specified by the shape interface. You're not limited to only the interface methods. Okay, 2 more thoughts. A class can implement more than one interface, so you're not bound by just a single interface. That'll be a little bit different from something we'll see shortly, which is that the subclass and superclass relationship doesn't really work in the same way. But as far as interfaces go, a class can implement more than one. And finally, interfaces themselves can have an inheritance hierarchy. And we'll see more about what that exactly means later. Okay, so before you close up shop, here's some ideas I'd like you to toy around with. Think about how you'd write an interface named account for bank accounts. Okay, clients should be able to make deposits and withdrawals and check their balances, given those 3 behaviors. So what would that interface, the account interface, look like? And just make sure you know, if a programmer uses the statement implements and then an interface name, for instance, implements shape or implements pen in a class definition, what does the compiler then expect? What must exist in the class that we define? That's it for now.